The next task that we're going to look at is called rationalizing the denominator. So first, what does it mean to rationalize and when do we do it? To rationalize means to eliminate or remove the radical sign in the denominator. So if the instruction is write your answer in simplest radical form, there should be no radical sign in the denominator. So for example, the denominator here is the square root of 3n. We know that neither 3 nor n is a perfect square. So this is not the simplest form. So how are we going to remove the radical sign, or how are we going to rationalize it? To do that, we're going to multiply by an expression that makes the denominator a perfect square. So what does that mean? For example, 3. We want to make 3 a perfect square, right? So is there any number here in the second column that 3 can turn into? So can we change it into a 4? No, because it says multiply. So there's no way we can multiply, 3 by a number and it will become 4. And take note, we're trying to look for whole numbers here, okay? So how about 9? Can we change 3 into a 9? Well, that's possible, right? We can multiply 3 by itself, okay, so that it will become 9. Well, what about the n? So we want n to be a perfect square. So in other words, you have to give it a partner. So that means you have to multiply the whole denominator by 3n. So let's do that. In other words, we're going to copy the same expression that we see in the denominator and multiply it to both the denominator and the numerator. There we go. So now what's going to happen? These two can be multiplied together. 5 times 3 is 15, but 15 is not a perfect square at all. So we're just going to put it in the radical sign. So 15 and the variable, which is n. Now for the bottom portion, 3 times 3 is 9. So let's put that together. 3 times 3 is 9, and n times n is n to the second power. So what's the square root of 9 again? The square root of 9 is 3, and the square root of n squared is n. So in other words, the square root of 9n squared is just equal to 3n. So if we go back here, we can just write it as 3n. So what happened? Did the radical sign disappear? Yes, it did. So by doing this trick, by copying the same expression and multiplying it by itself, we were able to cancel the radical sign, and then we just copy the same expression here. Of course, by doing that, it affected the numerator of our original expression. And this is okay. You can have a radical sign in the numerator, but not in the denominator. So that's why it's called you have to rationalize the denominator. Now, quick question. Can I divide the 15 here by 3 and cancel the n? Nope. So the 15, it's not a regular number anymore. It is under a radical sign. So think of these two expressions as, they're not like terms, so they can't now be simplified anymore. Okay, so the final answer here is square root of 15 over 3n. Now let's try another one. This time it has a cube root. Okay, so let's look at the third column here in our table. So is there a way we can change it to an 8? We can't make the number smaller. Okay, what about 27? There's a way we can change this 9 to a perfect cube, which is 27. How? What are we going to multiply it by? We're going to multiply it by 3, right? But since this is a cube root of 9, we're going to multiply this by the cube root of 3. So why? Well, because 9 times 3 is 27. And does 27 have a cube root? Oh, yes, it does, because it's a perfect cube. But don't forget that whatever you do to the bottom, you're gonna be fair and do it to the top. There you go. So in other words, you're not actually changing the original expression because you're just multiplying by 1. So if you write the same expression on top and bottom, this whole thing is just become 1. You're just rewriting it in a different way so you can turn your expressions into either perfect squares or cubes. So going back to our task, this is a regular number. It's an integer. This is a radical expression. So they can't go together inside the radical sign. They're not like terms. So that means we're just going to put them side by side. So 2 cube root of 3. Now what about the bottom? Ooh, let's see. We said earlier that 9 times 3 is 27, right? But it has a cube root. So the cube root of 27 is 3. So that means the whole expression can now be simplified into 2 cube root of 3 over 3. And that's the final answer. So that's our goal in rationalizing the denominator. You have to remove the radical sign in the bottom expression. Let's look at more examples. Here we go. So all of these are square roots, right? So for square roots, the shortcut is pretty much copy the same expression at the bottom, and then you multiply it to the bottom and to the top. There you go. So the final answer here will become 1 times radical 5 will just become radical 5 over, see, if you want, if you're not so sure about what to do, go ahead and multiply them. 5 times 5 is 25, right? But what is the square root of 25? It's 5. So this will be radical 5 over 5. Okay. Next one. So let's copy the expression at the bottom. Oh, why did I put an equal sign? Okay. Oh, that didn't sound. Okay. So let's multiply the top and the bottom by the same denominator, right? So you copy that, multiply it, both top and bottom. So now, let's simplify. We don't put 7 and 2 together in the radical sign. We keep the 7 outside, and then we copy the radical 2x. Okay, so now let's go. Multiply these together, because both of them have radicals. So 2 times 2 is 4, x times x is x squared. And both of them are inside the radical expression. Okay, so the top becomes 7 radical 2x. What's the square root of 4? 2. What's the square root of x squared? It's x, right? So the bottom line is, how do you know you're not messing up? Well, your final answer is actually the same as the original expression without the radical sign. Same thing here. The 2x is actually this, without the radical sign. But you probably are thinking, okay, then why do I have to do all these when I could just remove the radical sign? Well, you can remove the radical sign in the denominator, but you have to adjust your numerator, and by multiplying the same expression to the top, okay, you can simplify the expression to a radical expression on top, but a regular number or variable at the bottom. Okay, let's do some more. Let me just lower this down here. Okay. So the bottom is radical 3. So let's multiply radical 3 over radical 3. They both have radical, so you can combine them together, right? So radical 30 over, if you know your shortcuts, you could just write down your answer. So radical 3 times radical 3 will just be 3. If you're not so sure, you can go back. Radical 3 times radical 3 is a radical 9, right? But what is radical 9 again? It's 3. Okay, quick check. Can 3 divide a 30 or no? Well, in this case, this is a radical expression, this is a regular one, so don't divide. Okay, oh, what if both of them are inside a radical sign? Does it still work in the same way? Well, definitely, because you can break it down into 2 separate expressions, right? They're the same. This is equal. Okay, so now what are we going to multiply this with? We're going to multiply this by radical 3 over radical 3. So what happens? These both have radical expressions, so you can multiply them. You get 6y squared over, what's radical 3 times radical 3? We got here radical 9, so the bottom will be 3. Again, regular and a radical can't be simplified anymore. Okay, so those are more examples of simplifying by rationalizing the denominator.